Hello, welcome back to today's video. We're going to do the fourth Winter 2014-2015 Roundup video. Today we're going to look at things like sea surface temperature anomalies, solar activity, quasi-binary oscillation, and specifically for this video I want to focus on the Siberia, what's happening with Siberian snow cover, and in Scandinavia as well. I've got a huge amount of ground to cover for this video, so I've got to get on with things very quickly. So just quick to say about the ads. There's links to articles sitting underneath the weather video here on my home page at gazweathers.com and on many of the other pages as well. Have a browse through the widget. If there's any article that you're interested in, just click through when you finish at Gazweathers, of course, and you'll be able to go off and read those articles and at the same time you help to our website. Also say that there's green keyword ads on some of the pages, so you write your cursor over green keyword, they'll display ads, but if you click through the word, you go to Advertise website and you'll be able to support Gazweathers.com by doing that. And finally, the Discuss comment box has got an ad unit with it as well. It's right next to the Twitter feed. Again, have a browse through those ad units, through that ad unit or those ad units, and if there's anything you're interested in, just click through. You'll be able to go off and at the same time help support gazweathers.com. All these things are essentially paying for the website. They're allowing me to sit here and talk to you via Gazweathers, so thanks for getting involved and thanks for doing that. The links to most of these websites that you're going to see in this video can be found on my links page. You can see just about all the things in this video for yourself. And just say it's going to be a pretty long video, so if you can't watch it all in one sitting, it doesn't matter because it's going to be kept around Gazweathers indefinitely. So if you can't watch it all in one go, you can come back and watch the rest at a later date. And again, thanks for watching. It's going to be a long video, so thanks for sticking with it. Get yourself a cup of tea and a comfy chair and a biscuit. Going to be around for some time, but I hope you find the video interesting and informative. So let's start off with the sea surface temperature anomalies across the globe. We're specifically interested in the equatorial Pacific, and I've explained this in another video, but I have to assume that some people are watching this for the very first time, so I've got to go over it again. We're looking for El Nino, and El Nino means that we've got warm water along the equatorial Pacific just here, from Peru over here to Indonesia over here. And when we have warm water coming up along the equatorial Pacific, it basically means that we're in an El Nino state. We've got cold water coming up along here. It's the reverse. We're in a La Nina, but don't need to worry about that. We're not going to have a La Nina for this winter. Now, I want to go back to the last time we did this update, the third update. And this was sea surface temperature anomaly for the globe on the 2nd of October. And again, we're specifically interested in this area just here. I want you to look at this cold water that's stretching up from the coast of Chile through towards the equatorial Pacific. Keep an eye on that and go back to the latest chart, and there's been a definite shrinkage of that cold water away from the equatorial Pacific, and that has allowed warming to occur through this central part of the equatorial Pacific in the past couple of weeks. Go back to the situation on the 2nd, and I think you can quite clearly see, if we go forward again, that warming has occurred along the equatorial Pacific. Now, we can't say this is an El Nino. It isn't strong enough signal yet. It is a strong enough signature to be an El Nino, but certainly in the past couple of weeks things have shifted more towards an El Nino, so it could be that finally, it has been a slow old process, we're beginning to get this El Nino going. It's not going to be a strong El Nino. At the outside we could get to moderate later in the winter, although you would expect the El Nino really to peak around Christmas. I think it's going to be a weak El Nino, could be borderline moderate, but no more than that. It's far too late in the year to get a really strong El Nino going. And we're looking for this central part to be warmer than the Peruvian side of the equatorial Pacific. If we get this central part warmer, then it's a Modoki or Modiki or however you want to pronounce it, central based El Nino, and that can feed back to a cold winter for America, and also, importantly and crucially, a cold winter for Europe. So it could well be that the El Nino is on its way. I'll have a look at the SOI in a moment, Southern Oscillation Index. Now let's go up towards the northeastern coast of the northwestern coast, I should say, of America and Canada, and around to Alaska, the northeastern sort of Pacific. And again, I want to go back to the 2nd. Look how warm it was up there on the 2nd of October. Go back to the current situation, and it has cooled a little bit, hasn't it, up there in the far northeastern corner of the Pacific Ocean. Now, it's much, much warmer than it should be still up there. It's a lot warmer than you would expect. This is a pretty cold part, not just of the Pacific, but of the globe generally. It's one of the coldest parts of the oceans across the globe, this part of the Pacific. So it's a lot warmer than you would expect it to be, but nevertheless, cooling has taken place. The really cold water is over here on the northwestern side of the Pacific around Japan. That's where the coldest of the water is, but it is beginning to push through towards that northeast corner, gradually lowering the temperature. Now, I think we're still going to have warmer than average sea surface temperature anomalies up here through the course of the winter, but you will expect this to gradually start cooling down. It should start cooling down. I think probably it's going to be cooler in this corner of the Pacific than it was last winter. It's important because when it's very warm up here, it promotes a ridge around Alaska. When you've got a ridge up there, very often you get a trough, a cold trough, in the eastern and northeastern part of the United States. When you get that cold trough, depending on the setup in the Atlantic, it can spill the cold air out over the Atlantic and cause explosive cyclogenesis, deep areas of low pressure to sweep across the Atlantic into the British Isles and Europe over here. That's what happened last winter, but it does depend on the exact setup in the Atlantic, because if you get blocking, then with that very same pattern, you'll send the low pressures down towards Spain and Portugal, and northern parts of Europe could have a very snowy winter. But that's a very unusual pattern. When you've got a ridge up here, typically you get a trough there, and it'll cause Atlantic-based areas of low pressure to sweep through. So the fact things are cooling down, cooling down a little bit up here, could imply that the ridge around Alaska would be a little bit weaker than it was last winter. We'll see how that one goes, but overall I think the trends within the Pacific particularly are a little bit more encouraging than they have been if you want it to be colder this winter. In terms of the Atlantic, we haven't got the tripole, which is a warm, cold, warm band explained in other videos. We haven't got that, so really the Atlantic is still set up more or less for a positive NAO. Let's just have a look at the Southern Oscillation Index, see what that's doing. This is a reflection of the atmospheric setup, really, in the southern part of the Pacific. When it's negative, it's telling us that the atmosphere is reflecting El Nino, so the atmosphere and the oceans are coupling up to develop the El Nino. When it's positive, then you're in a La Nina phase. So if you've got an El Nino trying to develop, as we have been over the past few months, but the SOI is sort of going positive, and it's telling you that the atmosphere and the oceans are fighting against one another, and it's not coupling up to produce the El Nino. So let's just have a look and see how things have been going, and we can see that for the start of October, very much as it has been really through most of September, some days coming out negative, so 30th of September for instance minus 4.22, and at 7th of October minus 3.81, so sort of reflecting an El Nino type state. But in between we've been getting days, or we was getting days, sort of reflecting a La Nina state. So the 5th of October plus 8.89, for example, and the 8th of October plus 6.51. While you've got that going on, it's going to be very, very hard to get the El Nino going. While you've got some days reflecting a La Nina, some days reflecting an El Nino, the atmosphere and oceans are fighting against one another, you're going to really struggle. But in the last few days, we've gone definitively negative. Look at this. We've got the 11th, for example, of October coming out at minus 6, the 12th, minus 10, the 13th, minus 16, the 15th, minus 18. Very, very negative. That's the kind of thing we've been looking for. If we'd had that consistently from around July or August, we would be well and truly in this El Nino already. But because, as I say, the atmosphere and the oceans have been fighting against one another and been posting positive SOIs on some days, we've not got the El Nino going. But certainly in the past week we have generated some very negative numbers. For the very latest, for the 18th, comes out at minus 8.3, so not quite as negative as the day before, but still definitively on the negative side. If we can keep these very negative numbers going for the rest of October and into November, we will hook up that El Nino. And if of course, the warming that we've had in the central part of the Pacific through the equatorial Pacific has coincided in the past couple of weeks with this drop in the SOI. So I think things may be starting to happen there. We will have a look at that again in a couple of weeks when we do the 5th update. Solar activity next. This is the solar disk on our side of the disk from solarham.net today, and activity is officially moderate. We have got some sunspots, not that many, but it's this area just here, this big cluster right over on the excuse me, western limb of the Pacific, of the solar disk, just coming on to our side of the solar disk. Huge area of sunspot activity that could in fact ramp activity up into high category levels over the next few days, and it's sort of indicative that we're coming off the solar maximum. I'll explain this in other videos. We had the solar maximum last winter. We're coming off it now for this winter. We're gradually dropping down into towards solar minimum, which would occur around 2019, but it's not going to be a straightforward process, and we'll get some periods where we'll shoot up with the activity again. This is going to be one of those periods over the next couple of days, I think. And while you've got these big sunspots coming through, it just sort of niggles the jet stream, really. When you've got more solar activity, it enhances the jet stream. If you've got very weak activity, then it will tend to coincide with a weaker jet stream. That's the theory, anyway. So we're not in a great part of explaining this in other videos. We aren't in a great part of solar cycle 24 to get a cold winter. We're going to have to wait for 2 or 3 more years, maybe a couple of years, maybe 3 years, before this activity really drops off, going down into solar minimum. This just isn't the right time really to be generating cold winters. But because it's such a weaker cycle compared to most recent cycles, it does keep the interest going, really, because with solar cycle 24 being so much weaker than cycles that we had previously, it could allow for cold winters to occur even in this period that typically isn't great for a cold winter. Want to have a look at hurricane activity next. The theory behind this is that hurricanes are transporting warmth from the tropics in towards the polar regions. When you get a lot of hurricanes dumping a lot of warmth in the polar regions, it can eventually transfer that in towards an increased chance of blocking. We haven't had a big season, but we had more of a season we had last year in terms of hurricanes. We've had 7 total storms, 6 hurricanes, and 2, including one we've got at the moment, major category 3 or above hurricanes. Not going to be a huge hurricane season by any stretch of the imagination, but more than we had last year, when we barely had anything happening through the tropics at all. But I don't think this is going to have an effect, certainly in producing more blocking this winter. Just not enough hurricanes for that. Now, going through to the QBO, the quasi-biennial oscillation, don't want to dwell on this too much. We'll probably look at this more in a video in November, but we're going to be in the easterly phase of the QBO. On these charts, the easterly QBO is indicated by these white areas, and yeah, we're going to be in an easterly QBO. When you're in an easterly QBO, you increase your chance of a cold winter through blocking. The reason being that when you're in a westerly QBO, which are indicated by these grey areas, essentially you're enhancing the zonal westerlies around the northern hemisphere. So when the westerlies are stronger, as they are through these westerly QBOs, then obviously you're increasing the chance having a westerly winter. When the zonal westerlies weaken, as they do through these easterly QBO winters, then you increase the chance of forming blocks within the flow, blocking off the westerlies and getting a cold winter. Now, it's not as straightforward as that, because I've explained whilst there are quite a lot of winters that coincide with these easterly QBOs, for instance 2009, 2010, there's also a lot of winters that coincide, but also a lot of mild winters that coincide with the easterly QBO. So, for instance, 2007, 2008, and let's have a look at another one, 1998, 1999, easterly QBO winters that coincide with mild winters as well. So the QBO isn't the be-all and end-all, but nevertheless, it does increase your chance of a cold winter. I want to look at it in more depth, I think, as we go through into the future updates. Not sure it'll be the next update, but certainly one of the updates in November. We'll look a little bit more detail at the easterly QBO. Arctic sea ice and Siberian snow cover next, and just to confirm really where we finished up in terms of the Arctic sea ice melt season, we did pretty well. We was down on 2006, and that was our last sort of decent year in terms of how much ice we lost in the Arctic, so it's been a fairly big melt season again, but certainly it has been a death spiral year. We've not been down, for instance, with 2012 or let's say 2011 or another year, perhaps 2008. We've not been down in those very low years. We're not done as well as 2006. We've been somewhere on a par with last winter, and also with 2010, and also with what other year have we been with? 2013. So we've been okay. We've not lost as much ice as we have in some recent years. We've not done as well as the last year, but it was good in terms of how much ice we retained, which was 2006. We won't bother looking at that again because that's finished. It's going to be upwards now with the sea ice through into the winter. Remember, when you lose a lot of ice, as we did for instance in 2012, the theory is that it can feed back into an increased chance of blocking. So the fact we haven't lost too much ice from the Arctic this winter, although we have lost quite a lot, but the fact it's not been a death spiral year, could sort of go against a chance of a cold winter, but let's not worry about that. But good news, I think we've got to agree that it is good news, is that for another year we've done okay, not brilliant, but okay with the sea ice. It'll be interesting how much we lose next year if this El Nino does couple up, because eventually the warmth from the Pacific, the equatorial Pacific, can finish up in the Arctic, and that can put pressure on the ice. So very often it's the year after an El Nino that you'll lose a lot of ice. We'll see how that one goes. Siberian snow cover next, and look how well we're doing with the Siberian snow cover this year. Look at all this snow that got stretched out across the Siberian plain, doing really, really well. Also stretching it into Scandinavia, importantly, and even into western parts of Russia. This is very much above where you would expect to be with the Siberian snow cover at this time of year. The only other year that I can find that is on a par with this is 2002, this one just here, and even that, I think, even then, in 2002, I think we have less ice, less snow than we have at the moment. Go back to the situation now, and I think we've got more now. We've definitely got more now over Scandinavia. That's important. It's not as much how much snow cover you've got that's crucial. Actually, it's where the snow cover is developing. In 2002, we didn't have all that much over Scandinavia, although we did have quite a lot through Siberia, but we didn't have a great deal over Scandinavia. And that was quite a mild winter, actually, 2002-2003. There was some decent cold snaps, particularly at the start of January 2003, but overall, pretty mild winter. And despite the fact that we built the snow cover up very nicely across Russia and Siberia. But the difference, perhaps this year to 2003, as I say, is that we don't generate it that quickly over Scandinavia in 2002, whereas now we've got really decent cover there for the time of year across central northern parts of Norway, Sweden, and backing into Finland as well. Let's have a look at 2013, see how we're comparing to that. We're above 2013. Now, we built the snow cover up very quickly in 2013 last year through this central and eastern part of Russia. We didn't push it much further west than this, though. We got to this point, and really we stalled it at this point through the rest of October. So that was the problem last year. We had a very quick start in the eastern Siberia. We didn't get it into west. We didn't progress much further than this through the course of October. And again, notice Scandinavia, significantly less snow cover than we've got right now. 2009 is an interesting year. That was a cold winter, 2009, 2010. Sure, remember it very well. And it was a very slow start, actually, to the snow cover across Scandinavia, across Siberia. But notice over Scandinavia, we're doing very well. A very unusual year, 2009. It was really, really slow getting the cover going across Russia, but we did build it up very quickly over Scandinavia. And as we go through to 22nd of October 2009 and on into the 27th of October 2009, we do gradually push the snow into Russia and Siberia, of course. But again, we don't back into west of Russia that quickly. So that wasn't great actually, but the important factor for 2009, as I say, was that we built this snow cover a lot over Scandinavia, and I think that made the difference for that winter. And also, of course, the thing about 2009, 2010 is that it was a very much in the depths of the solar minimum, as we was going from solar cycle 23 to solar cycle 24. Hardly any solar activity at all, and that, I'm sure, played a big part in the cold winter. But it's very interesting. I want to go back to the current snow cover chart. Very interesting that for Russia and Siberia, we're just about above any other year in terms of the snow cover, perhaps on a par with 2002, but I think even there we're a little bit above 2002. But the big difference between this year and 2002 is that we're generating snow cover much more widely up over Scandinavia. Now, I can't go without talking about the OPI, the October Pattern Index. This has been generating a huge amount of interest on the forums and on social media over the past few weeks. It's a methodology that I'm not particularly comfortable talking about because I hadn't really heard a great deal about it. I did hear a little bit about it last year, but heard a lot more about it this year, but I'm still not all that comfortable with the methodology. But the idea essentially is that when the OPI, the October Pattern Index, is negative, as it is this year, minus 2.86 is the current provisional forecast from today, I'm doing video the 18th to the 28th of October. When it's negative, when the October Pattern Index is negative, it's telling us that we've got blocking up over the Arctic, and that should eventually, as you get through to winter, feed back into a negative Arctic oscillation, increased risk of blocking. And it probably does it. Don't want to say too much about it because I say it's not something I'm comfortable with. It probably does it because of this. So it could essentially be another way, really, of talking about what we've been talking about already, which is how quickly the snow cover is building up across Russia and how quickly it's building up over Scandinavia. When you've got the blocking over the pole, you build the snow cover up more quickly over Scandinavia and Russia. Probably another way of talking about that, but the crucial point is that the OPI for this year is forecast to be very negative, certainly up to the 28th of October. It's not a done deal. We've got a few more days to go before we get the actual forecast for the months coming through. But it's been negative through most of the month. If I scroll down, you can see that most days through this month have been posting negative returns. It's forecast to stay very negative through towards the end of the month. This should increase our chance of more blocking over the pole. Doesn't guarantee a cold winter, of course, because as I've explained in other videos, even though you've got blocking over the Arctic, you've got negative Arctic oscillation, it's where that blocking's sitting that's crucial. And if you don't get a block in exactly the right position, we won't get the cold coming down. But certainly, it's a bigger increase chance when you've got a lot of blocking over the pole of getting a colder winter, obviously. So the OPI is very interesting. I'm hoping to have more about it on the blog. The authors of this are based in Italy. I've been doing a little bit of emailing with them. I'm hoping to get the actual forecast that they are going to produce at the start of November on the blog. Hoping to get it on the blog at the start of November when they produce that forecast based on this OPI methodology. So a very interesting update here for people who like cold, want it cold, and so by no means is anything that you've seen here a guarantee of a cold or a snowy winter, but certainly things looking a little bit more promising than the very bleak update that we did a couple of weeks ago. We're going to have to wait and see how things develop in the Pacific. We're going to have to wait and see how the OPI finishes up, and of course whether we maintain this pretty good or very good snow cover that I've got across Russia and especially into Scandinavia. So very interesting update. Hope you found the video interesting and informative, and that's all for now. Next week we're going to get all the seasonal models together and see what they're showing for winter. The second seasonal model roundup will be coming up next week. The week after that we'll do the fifth winter 14-15 update, and that will have the information about the OPI, El Nino and all the rest. So that's all for now. Thanks for watching.